maximum stress and minimum stress will give us a straight line. Will give us a straight line like this. This is called as mean stress. This stress value is called as mean stress. The important thing that you need to notice here, there is a minimum value of stress. So sigma minimum is the minimum value of stress. This value of stress is present at all times. This is the least value of stress that is present at all times. As and when time progresses, the value of stress varies from sigma minimum, that is the minimum value, to a maximum value which is represented by sigma max. Now, since this is a wave form, the average of maximum stress and minimum stress is what we call as mean stress, which is represented by this dotted line. This is called as mean stress. Now, what is stress amplitude? Stress amplitude is the maximum displacement. Stress amplitude is the maximum displacement Okay, is my voice clear? Okay, fine.
Yes, sir.
Now, what is stress amplitude? Stress amplitude is the maximum displacement of the wave from the mean position. Mean stress line in the maximum stress deviation agide. That is what we call as stress amplitude. Now, based on this curve, how can I represent stress amplitude? Stress amplitude, I am representing it by the notation sigma A. Sigma A is the stress amplitude. Can I write it to be sigma max minus sigma minimum by 2? Correct? What is sigma max minus sigma minimum by 2? This is sigma max. This is sigma minimum, right? The difference between these two is this line. This is the difference between sigma max and sigma minimum. Half of sigma max minus sigma minimum will give me the value of stress amplitude. ಅರ್ಥ ಆಗಿದೆಯಾ ಈ ಫಾರ್ಮುಲಾ ಹೇಗೆ ಬಂತು ಅಂತ? ಅರ್ಥ ಆಯ್ತಾ ಈ ಫಾರ್ಮುಲಾ ಹೇಗೆ ಬಂತು ಅಂತ? Can you guys hear me?
Yes, sir.
Okay, fine. ಇದು ಅರ್ಥ ಆಗಿದೆಯಾ ಸ್ಟ್ರೆಸ್ ಆಂಪ್ಲಿಟ್ಯೂಡ್ ಫಾರ್ಮುಲಾ ಹೇಗೆ ಬಂತು ಅಂತ?
Yes, sir.
Okay, fine. Now let us try to do the same thing for mean stress. Mean stress we are representing it using the notation sigma m. What is sigma m? Sigma m is the maximum stress plus the minimum stress. This is the maximum stress. This is the minimum stress. Half of it will give me the intermediate value between the maximum value and minimum value. So thereby sigma m, that is the mean stress, can be calculated using the formula sigma max plus sigma minimum by 2, right? So this will be the formula for calculating the mean stress of the component. ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ ಈ ಫಾರ್ಮುಲಾ ಹೇಗೆ ಬಂತು ಅಂತ?
Yes, sir.
Right. Now that is the terminology that I am giving it here. So this is whenever we are solving problem, we will always make use of this these formulae to calculate the maximum stress amplitude as well as mean stress induced in the component. Now let us look at certain specific cases. What happens when certain specific types of loads are applied. So now if you look at this graph, again I have stress along y-axis and time along x-axis. If you look at this, the reason that I am highlighting it in yellow, now what can you say by looking at this graph? Can I say that this is basically representing the minimum stress induced in the component? How that? This value is basically representing sigma m. That is the lowest portion of the curve will always represent sigma minimum. This is the minimum stress induced. Now what is the value of minimum stress here? As you can see, the value of the minimum stress is 0. The value of minimum stress is 0. Beginning with 0, it is reaching a maximum value sigma max, and after a certain interval of time, it is again touching back the x-axis. It means to say that the minimum stress induced in the component is 0. If the minimum stress induced in the component is 0, then the curve will start from 0. It will go back to a highest value. It will go back to a peak, as I am highlighting it in pink. It will reach the maximum value and it will come back to 0. Such a type of force, or such a type of stress induced, is called as repeated stress. Why do we call it as repeated stress? Say if the maximum stress induced is 100 MPa, this maximum stress of 100 MPa is repeating itself after a certain interval of time with minimum stress being equal to 0. Such a type of stress is called as repeated stress. Repeated stress antandreno, the minimum stress induced in the component will be 0. It will reach a peak value and it will come back to 0 and the cycle will continue. Such a type of stress is called as repeated stress. ಅರ್ಥ ಆಗಿದೆಯಾ the concept? Is the concept clear? I want someone to respond. ಕೇಳಿಸ್ತಾ ಇದೆಯಾ ನಾನು ಮಾತಾಡ್ತಾ ಇರೋದು?
Yes, sir, it's audible.
Okay, fine. ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಯ್ತಾ ಇದು?
ಸರ್ ಇನ್ನೊಂದ್ಸತಿ ಹೇಳಿ ಸರ್.
ಸೊ ಈ ಕೇಸಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, as you can see, minimum stress induced 0. ಈ ಕರ್ವ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಈ ಕರ್ವ್ ಅಲ್ಲಿ ಮಿನಿಮಮ್ ಸ್ಟ್ರೆಸ್ 0 ಇರಲಿಲ್ಲ. ಇಟ್ ವಾಸ್ ಸಮ್ ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ. ದಿ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸಿಗ್ಮಾ ಮಿನಿಮಮ್ ವಾಸ್ ನಾಟ್ ಈಕ್ವಲ್ ಟು 0 ಇನ್ ದಿಸ್ ಕೇಸ್. ಸೊ ಇಲ್ಲೇನು, ದಿಸ್ ಇಸ್ ಅ ಸ್ಪೆಷಲ್ ಕೇಸ್. ಏನಾಗ್ತಾ ಇದೆ, ಆ ಕರ್ವ್ ಮೇಲೆಲ್ಲೋ ಇದ್ದಿದ್ದು ಕೆಳಗಡೆ ಬಂದು ಸಿಗ್ಮಾ ಮಿನಿಮಮ್ ಇಸ್ ನೌ ಈಕ್ವಲ್ ಟು 0. ಈ ಕೇಸಲ್ಲಿ ಏನಾಗುತ್ತೆ, 0 ಇಂದ ಎಷ್ಟೋ ಮ್ಯಾಕ್ಸಿಮಮ್ ವ್ಯಾಲ್ಯೂ 100 MPa ಇದೆ ಅಂತಂದ್ರೆ 0 ಇಂದ 100 MPa ರೀಚ್ ಆಗುತ್ತೆ. ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್ ಟು 0. ತಿರ್ಗಾ 100 MPa ರೀಚ್ ಆಗುತ್ತೆ. ಅಗೇನ್ ಇಟ್ ವಿಲ್ ಕಮ್ ಬ್ಯಾಕ್ ಟು 0. ಈ ಸೈಕಲ್ ಕಂಟಿನ್ಯೂ ಆಗುತ್ತೆ. ಮಿನಿಮಮ್ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾದ್ರೂ 0 ಇದ್ರೆ, ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ರಿಪೀಟೆಡ್ ಸ್ಟ್ರೆಸ್. ಅರ್ಥ ಆಯ್ತಾ ಇದು ಕಾನ್ಸೆಪ್ಟ್? ಸೊ ಈ ಕೇಸಲ್ಲಿ ಸಿಂಪಲ್ ಆಗಿ ಮಾಡ್ಕೊಳ್ಳಿ, ಮಿನಿಮಮ್ ಸ್ಟ್ರೆಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. ಸೊ ಮಿನಿಮಮ್ ಸ್ಟ್ರೆಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಇದ್ರೆ ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್ ಟು ಮೀನ್ ಸ್ಟ್ರೆಸ್? ಮೀನ್ ಸ್ಟ್ರೆಸ್ ನ ಸಿಗ್ಮಾ ಎಂ ನ ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡಿದ್ವಿ ನಾವು? ಸಿಗ್ಮಾ ಎಂ ವಾಸ್ ಸಿಗ್ಮಾ ಮ್ಯಾಕ್ಸ್ ಪ್ಲಸ್ ಸಿಗ್ಮಾ ಮಿನಿಮಮ್ by 2, sigma max plus sigma minimum by 2. Here sigma minimum is equal to 0. ಹೌದಾ? So sigma m will be equal to sigma max by 2. Correct? So the mean stress will be equal to sigma max by 2. So ಈ ಕೇಸ್ ನ ಹಾಗೆ ನೋಟ್ ಮಾಡ್ಕೊಳ್ಳಿ. When the load is repeated in nature, the mean stress will be sigma max by 2. Now what will happen to the stress amplitude? Stress amplitude na hege represent ಮಾಡಿದ್ವಿ, sigma a was equal to sigma max minus sigma minimum by 2. Sigma max minus sigma minimum by 2. Again here the minimum stress is 0. So thereby the stress amplitude will also be equal to sigma max by 2. Or in other words,
ನೀವೇ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀರಾ?
ವೇದಮೋಹನ್ ಸರ್ ಹಾಕಿದ್ದಾರೆ, ನೀವೇ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀರಾ ಅಥವಾ ಏನು ಅಂತ ಸರ್?
ವೇದಮೋಹನ್ ಸರ್ ಮೆಸೇಜ್ ಹಾಕಿದಾರಾ?
ಎಸ್ ಸರ್, ಇವಾಗ ಹಾಕಿದ್ದಾರೆ.
just 2 minutes. ವೇದಮೋಹನ್ ಸರ್ ನಾನು ಹೇಳ್ತೀನಿ, ಒಂದು 10 ನಿಮಿಷ ಕಂಟಿನ್ಯೂ ಮಾಡ್ತೀನಿ ನಾನು.
ಓಕೆ ಸರ್.
You guys stay online. I will take the class till 10:15. I will just call Vedmohan sir and I will inform him. Okay, the class will begin by 10:15. I will just extend and I will just complete this concept, right? So, in other words, both stress amplitude as well as mean stress will have the same value. ಯಾವಾಗ repeated stress ಇದ್ದಾಗ. ಅರ್ಥ ಆಗಿದೆಯಾ ಅದು ಕಾನ್ಸೆಪ್ಟ್? Is the concept clear? Am I audible?
Yes, sir.
ಓಕೆ ಫೈನ್. ಈ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಆಗಿದೆ ಅಲ್ವಾ?
ಎಸ್ ಸರ್.
ಫೈನ್. ರಿಪೀಟೆಡ್ ಸ್ಟ್ರೆಸ್ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ? ರಿಪೀಟೆಡ್ ಸ್ಟ್ರೆಸ್ ಇದ್ದಾಗ ಮೀನ್ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಮಿನಿಮಮ್ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ 0. ಮಿನಿಮಮ್ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ 0 ಇರೋದ್ರಿಂದ ಮೀನ್ ಸ್ಟ್ರೆಸ್ as well as stress amplitude will have the same values. Now let us look at another case. Now you observe, this is the maximum stress induced, this is the minimum stress induced. The maximum stress induced is sigma max. The minimum stress induced here is minus sigma max. ಅಂದ್ರೇನು? ಈ ಕೇಸಲ್ಲಿ ಸಿಗ್ಮಾ ಮ್ಯಾಕ್ಸ್ ಏನಿದೆ, ಇವಾಗ ಸಿಗ್ಮಾ ಮ್ಯಾಕ್ಸ್ 100 MPa ಇದೆ ಅಂತ ಅನ್ಕೊಂಡ್ರೆ, ದಿ ಮಿನಿಮಮ್ ಸ್ಟ್ರೆಸ್ ಇಂಡ್ಯೂಸ್ಡ್ ಇನ್ ದಿ ಕಾಂಪೊನೆಂಟ್ ಇಸ್ minus 100 MPa. ಹೌದಾ? ಸಿನ್ಸ್ ದಿ ಕರ್ವ್ is extending towards the top of x-axis as well as towards the bottom of x-axis at same amplitudes, the maximum stress induced is equal in magnitude to the minimum stress induced, but it is only different in direction. So maximum stress value positive ಇದೆ, minimum stress value negative ಇದೆ. So in this case what will happen? As you can see, the mean stress line is sitting at x-axis itself. So thereby sigma m is equal to 0. ಅಂದ್ರೇನು? sigma m is sigma max plus sigma minimum by 2. So since sigma minimum is minus sigma max, sigma minimum is minus sigma max, what will happen? So sigma mean is sigma max plus minus sigma minimum by 2. So this will get cancelled and it will be equal to 0. So thereby sigma m will be equal to 0. But what will happen to stress amplitude? Sigma a is sigma max minus sigma minimum. So here minus sigma minimum is minus sigma max itself, because it is only different in this sign by 2. So sigma max minus of minus sigma max is 2 sigma max. 2 sigma max by 2 is sigma max. Howda? So the stress amplitude here will be equal to sigma max. So thereby sigma a will now be equal to sigma max. Correct? So here sigma m is equal to 0 and sigma a is equal to sigma a will be equal to sigma max. ಅರ್ಥ ಆಗಿದೆಯಾ ಇದು? Is the concept clear? ಅರ್ಥ ಆಗಿದೆಯೇನ್ರ ಇದು?
ಸರ್.
Fine. Now what we will do, in the previous problems that we have solved, I was speaking about material property. Why do we need material property? So material property will indicate the strength of the material to resist a particular type of force. It will indicate the strength of a material to resist a particular type of force. Now in the previous cases we considered yield strength to be the material property. So whatever problems that we were solving, whenever we are making use of the condition for safe design, we were comparing the stress induced to the yield strength of the material. Now yield strength, as you can know, the yield strength of the component is particularly tested by applying a static force. Now similarly, when the component is subjected to a dynamic force, when the component is subjected to a fatigue load, it becomes necessary to determine the strength of the material when it is subjected to fatigue loading. So thereby there was a person called as R.R. Moore. There was a scientist called as R.R. Moore. So he devised a technique to determine the fatigue strength of the material. So the testing equipment that we made use of is called as R.R. Moore fatigue testing machine. This is you have already studied this when you are in third semester, that is in your material testing laboratory, where we determined something called as endurance limit of the material. Probably since we should make use of multiple number of specimens to test it, ಇದನ್ನ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ನ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಮಾಡಿಸಿರಲ್ಲ. ಬಟ್ ಏನ್ ಮಾಡಿರ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ, ನಿಮ್ಗೆ ಒಂದು ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಕಂಡಕ್ಟ್ ಮಾಡಿ, ಫೆಟಿಗ್ ಟೆಸ್ಟ್ ಅಂತ ಒಂದು ಟೆಸ್ಟ್ ಕಂಡಕ್ಟ್ ಮಾಡಿ, ಒಂದು ಮೈಲ್ಡ್ ಸ್ಟೀಲ್ ಸ್ಪೆಸಿಮನ್ ನ ತಗೊಂಡು ಆ ಸ್ಪೆಸಿಮನ್ ಅನ್ನ ರೊಟೇಟ್ ಮಾಡ್ತೀರಾ ಕಂಟಿನ್ಯೂಸ್ಲಿ ಬೈ ಕನೆಕ್ಟಿಂಗ್ ಇಟ್ ಟು ಅ ಮೋಟಾರ್. ಯು ವಿಲ್ ನೋಟ್ ಡೌನ್ ದಿ ನಂಬರ್ ಆಫ್ ಸೈಕಲ್ಸ್ ಟು ಫೇಲ್ಯೂರ್. ಈ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡಿದೀರಾ? Do you guys remember the experiment?
No, sir. ಮಾಡ್ಸಿಲ್ಲ ಸರ್.
ಮಾಡಿಸಿಲ್ವಾ ಅದನ್ನ? Okay, fine. ಅಕಸ್ಮಾತ್ ಕಾಲೇಜ್ ಸ್ಟಾರ್ಟ್ ಆದಾಗ I can take you and show that experiment. The facility is there in our lab. So basically what we will do, there is a little bit of error that we had, the procedure that we had followed in the material testing laboratory. Specimen ಅನ್ನ ರೆಗ್ಯುಲರ್ ಆಗಿ ಡಾಗ್ ಬೋನ್ ಸ್ಪೆಸಿಮನ್ ಟೆಸ್ಟ್ ಮಾಡಿದ್ವಿ. But what needs to be done, the figure that you are seeing here is the test specimen for carrying out fatigue testing, right? So basically ಏನಾಗಿದೆ, the length of this specimen is 85 mm. This is the specification of the test specimen as per ASTM standard. ನಾವು ಇಲ್ಲಿ ಏನಾಗಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಈ ಪೋರ್ಷನ್ ಇಂದ ಒಂದು ಅವರ್ ಗ್ಲಾಸ್ ಶೇಪ್ ಸ್ಪೆಸಿಮನ್ ನ ಕಟ್ ಮಾಡಿದೀವಿ, ರೈಟ್? ಸೊ ಅವರ್ ಗ್ಲಾಸ್ ಶೇಪ್ ನ ಸ್ಪೆಸಿಮನ್ ನ ಕಟ್ ಮಾಡಿದೀವಿ, whose radius is 250 mm. The radius of this hourglass contour is 250 mm and the minimum diameter ಅಂದ್ರೆ ಈ ಮಧ್ಯದಲ್ಲಿ ಏನ್ ಡಯಾಮೀಟರ್ ಬರುತ್ತೆ, so this diameter is 7.5 millimeters. This diameter is 7.5 millimeters. Now basically this is the dimension of the component that ASTM, that is American Society for Testing of Materials, recommends. Now what we will do, I will share this presentation with you. The dimensions as well as the shape of it is very important because this is one important question in your examination. Mark ಮಾಡ್ಕೊಳ್ಳಿ. So hardly module 1 ಮತ್ತೆ module 2 ಇಂದ ನಿಮಗೆ 10 to 15 marks ಗೆ ಥಿಯರಿ ಕ್ವೆಶ್ಚನ್ ಬರ್ಬೋದು. ಆ 10 to 15 marks ಗೆ ಬರೋ ಥಿಯರಿ ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲಿ the concept of stress concentration and the methods of reducing it that we had discussed in the previous module, that is one important theory question. The second and most frequently occurring theory question is fatigue strength estimation by using RR-Moore fatigue testing machine. So this is a commonly asked question in your examination. You just mark it as important. Now what we will do, we will make use of the specimen, and this is the test equipment that we have. So basically what we will do, we will take this specimen and we will mount it in between two couplings. The coupling will be connected to an electric motor and there will be a revolution counter here. This is a revolution counter. So what it will do, it will count the number of revolutions that the component will take, right? Then what we will do, we have a mechanism that is present here to increase the force that is acting on the specimen. So as you know, by increasing the force, the stress induced in the specimen will also increase. So what is the effect of adding the force this way? This force, that is these dead weights, are trying to bend the component, right? This force are trying to bend the component. So basically what will happen, because of the application of these dead weights, the component will be subjected to a bending moment. Also, since it is connected to an electric motor and since it is continuously rotated, it will also be subjected to a twisting moment, MT. So basically what will happen, so here this specimen is subjected to combined bending and torsion, correct? Here the specimen is subjected to combined bending and torsion. So this is a type of combined loading. So continuously it is subjected to bending and torsion. So what we will do, we will take that specimen. One important thing that you need to remember is this specimen is always mirror polished. This specimen is always mirror polished. What do we mean by being mirror polished? So basically ಏನ್ ಮಾಡ್ತೀವಿ, ರೋಲ್ ಮಾಡಿದ್ಮೇಲೆ ಡೈಮೆನ್ಷನ್ ಗೆ ಟರ್ನ್ ಮಾಡಿದ್ಮೇಲೆ ಏನ್ ಮಾಡ್ತೀವಿ, we will do a buffing operation where the surface scratches. ನಾನು fatigue crack propagation ಬಗ್ಗೆ ಹೇಳ್ತಿದ್ನಲ್ಲ, that is mechanism of fatigue failure. So surface ಅಲ್ಲಿ scratches ಇರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ದೆ, which will act as a region of stress concentration. So basically what we will do here, so here we will polish this specimen in such a way that it appears as a mirror. So it is almost similar to these Belgium mirrors, those costly mirrors that you see. So thereby preparation of this specimen is a very costly task. So there should not even be a minute scratch even when you observe it under a microscope with a magnification factor of somewhere around 30x. So that is the level of finish that is required. So it is a carefully polished specimen. We will take it, we will subject it to combination of bending and torsion. So what we will do, say, let me say that I will go with the highest value of stress. Say ಒಂದು 500 MPa stress apply ಮಾಡ್ಬಿಡ್ತೀನಿ ಡೈರೆಕ್ಟ್ ಆಗಿ. So I will make sure that the component is stressed to a level of 500 MPa. Then what I will do, I will set the component to rotate. I will set the component to rotate. So what will happen? It will rotate for a predefined. It will rotate for a certain number of cycles, and the component will break outrightly. Yield agalla, because as I was telling, it is very much similar to brittle failure. Even though the material is ductile in nature, it is very similar to brittle failure. So it will undergo a certain number of cycles, and it will break. So what I will do, I will come back. I will make use of a graph sheet in the form of logarithmic graph sheet. Logarithmic graph sheets ಅಲ್ಲಿ ಎರಡು ತರ graph sheets ಬರುತ್ತೆ. ಒಂದು log plot, ಇನ್ನೊಂದು semi log plot. log plot ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ, ಒಂದೇ ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ, say in x axis we will have a logarithmic scale, but whereas in y axis we will have a normal scale. But log plot ಅಲ್ಲಿ ಏನ್ ಮಾಡ್ತೀವಿ, both along x axis as well as y axis we will have a logarithmic scale. So then what I will do, so you say I have applied a stress of 500 MPa, and you assume that the component will fail at 10 to the power of 3 cycles, or 10 to the power of 3.5 cycles. So this is 10 to the power of 3, 4, 5, and it is 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, and so on. Similarly, the same thing will happen here, beginning with 10 to the power of 3, 4, 5, 6, and so on. The component will fail at a particular stress value. This is log of stress. This is log of stress to failure. This is log of number of cycles to failure. So 500 MPa stress value li 10 to the power of 3, 3.5 ಅಲ್ಲೆಲ್ಲ ಫೇಲ್ ಆಗಿದೆ. ಈ ಪಾಯಿಂಟ್ ನ ಮಾರ್ಕ್ ಮಾಡ್ತೀನಿ. Then what I will do, I will go back, I will reduce the magnitude of stress, say to 400 MPa. I will reduce the magnitude of stress. Then I will set the machine to operate. Then the component will again take a certain number of cycles to failure. The component will take a certain number of cycles to failure, and it will fail at a particular point. So ಈ ಕೇಸಲ್ಲಿ ಕಾಂಪೋನೆಂಟ್ ಬೇಗ ಫೇಲ್ ಆಗುತ್ತಾ ಅಥವಾ ಇನ್ನೂ ಜಾಸ್ತಿ ಟೈಮ್ ತಗೊಳುತ್ತಾ ಫೇಲ್ ಆಗಕ್ಕೆ? I want someone to respond. You just make it quick. Will the component fail at 10 to the power of 3 cycles itself, or will it take more number of cycles to fail? Can someone answer, Sagar? Sagar? Am I audible? Ratvik?
Yes, sir.
Okay. Sagar, ಕಾಂಪೋನೆಂಟ್ ಬೇಗ ಫೇಲ್ ಆಗುತ್ತಾ ಅಥವಾ ಜಾಸ್ತಿ ಟೈಮ್ ತಗೊಳುತ್ತಾ ಫೇಲ್ ಆಗಕ್ಕೆ? ಏನಾದ್ರು ಹೇಳ್ರೋ?
ಸರ್ ಬೇಗ ಆಗುತ್ತೆ.
ಜಾಸ್ತಿ ಸೈಕಲ್ಸ್.
So it will take more number of cycles to fail. Why? Because I am reducing the force that is applied. Thereby the stress induced this law, stress kadame aagta ide anta helidre, it can take more number of cycles. Hauda? It will, the life of the component will be increased if the force is decreased. This is one thing that you need to remember. So 400 MPa apply ಮಾಡಿದಾಗ ಏನಾಯ್ತು, ಎಲ್ಲ 10 to the power of 4.5 cycles ಬಂತು. So ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಅದೇ ತರ gradually I will go on decreasing the force, and I will go on plotting this curve. So ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಇಲ್ಲಿ ಪ್ಲಸ್ ಕಲರ್ಡ್ ರೀಜನ್ಸ್ ಏನಿದೆ, ದೇ ಆರ್ ಫೇಲ್ಯೂರ್ ಪಾಯಿಂಟ್ಸ್. ಸೊ ASTM ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಏನ್ ರೆಕಮೆಂಡ್ ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, ಐ ನೀಡ್ ಟು ಟೆಸ್ಟ್ 3 ಸ್ಪೆಸಿಮೆನ್ಸ್ ಅಟ್ ಈಚ್ ಲೆವೆಲ್. ಅಂದ್ರೆ ಏನು, 500 MPa ಅಲ್ಲಿ ಐ ವಿಲ್ ಟೆಸ್ಟ್ 3 ಸ್ಪೆಸಿಮೆನ್ಸ್.
ಸರ್ ವೇದಮೋಹನ್ ಸರ್ ಲಿಂಕ್ ಹಾಕ್ತಿದ್ದಾರೆ ಜಾಯಿನ್ ಅಂತ.
ಹಾಗೆ ಒಂದು 10 ಮಿನಿಟ್ಸ್ ಬಿಟ್ಕೊಂಡು ಜಾಯಿನ್ ಆಗಿತ್ತು, ಕಳಿಸ್ಕೋಬೇಡಿ. ಇದೊಂದು ಹೇಳ್ಬಿಡ್ತೀನಿ, ಡೋಂಟ್ ವರಿ, ನಾನು ವೇದಮೋಹನ್ ಸರ್ ಹೇಳಿದ್ದೀನಿ. ಸೊ ನಾನು ಪ್ರತಿಯೊಂದು ಟೆಸ್ಟ್ ಲೆವೆಲ್ ಅಲ್ಲೂ ಐ ವಿಲ್ ಟೆಸ್ಟ್ 3 ಸ್ಪೆಸಿಮೆನ್ಸ್. ಯಾಕೆ ಅಂತ ಹೇಳಿದ್ರೆ, 3 ಸ್ಪೆಸಿಮನ್ ನ ಟೆಸ್ಟ್ ಮಾಡಿದಾಗ 100% ಇವಾಗ 10 to the power of 3 ಬಂದ್ರೆ, ಅಂದ್ರೆ 10,000 ಸೈಕಲ್ಸ್ ಬಂದ್ರೆ, ನೆಕ್ಸ್ಟ್ ಇದ್ರಲ್ಲೂ 10,000 ಸೈಕಲ್ಸ್ ಬರಲ್ಲ. 10,000 ಸೈಕಲ್ ಒಂದ್ಸಲ ಬಂದಿದ್ರೆ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಪ್ರಾಬಬ್ಲಿ 10,100 ಬರ್ಬೋದು, ಅದರ ನೆಕ್ಸ್ಟ್ ಟೈಮ್ 9,900 ಬರ್ಬೋದು. ಡೇಟಾ ಸ್ಕ್ಯಾಟರ್ ಆಗಿರುತ್ತೆ. ಸೊ ನಾನು ಏನ್ ಮಾಡ್ತೀನಿ, ಪ್ರತಿಯೊಂದು ಟೆಸ್ಟ್ ಲೆವೆಲ್ ಅಲ್ಲೂ ಐ ವಿಲ್ ಟೆಸ್ಟ್ 3 ಸ್ಪೆಸಿಮೆನ್ಸ್, ಅಂಡ್ ಐ ವಿಲ್ ಪ್ಲಾಟ್ ದಿ and I will mark the failure points on this line as indicated just by these plus colored lines. then I will fit a curve that best matches these lines. ಸೊ ಆ ತರ ಮಾಡಿದಾಗ ಏನಾಗುತ್ತೆ ಹೇಳಿದ್ರೆ ಈ ತರ ಒಂದು ಲೈನ್ ಬರುತ್ತೆ ನನಗೆ. ಸೊ ನಾನು ಏನ್ ಮಾಡಿದ್ದೀನಿ, ಒಂದು ಕಾಂಪೋನೆಂಟ್ ತಗೊಂಡಿದ್ದೀನಿ, ಆ ಕಾಂಪೋನೆಂಟ್ ನ ಡಿಫರೆಂಟ್ ಸ್ಟ್ರೆಸ್ ಲೆವೆಲ್ಸ್ ಗೆ ಸಬ್ಜೆಕ್ಟ್ ಮಾಡಿ ಐ ಹ್ಯಾವ್ ನೋಟೆಡ್ ಡೌನ್ ದಿ ನಂಬರ್ ಆಫ್ ಸೈಕಲ್ಸ್ ಟು ಫೇಲ್ಯೂರ್. ಐ ಆಮ್ ಪ್ಲಾಟಿಂಗ್ ಇಟ್ ಆನ್ ಎ log plot. I will get a graph like this. As you can observe, for all ferrous materials you will get a graph like this. ಏನಾಗುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಸ್ಟ್ರೆಸ್ ಲೆವೆಲ್ ನ ಕಡಿಮೆ ಮಾಡ್ತಾ ಬರ್ತಿದ್ದಾಗೆ, as and when you decrease the stress level, the number of cycles to failure will go on increase, and it will come to a point which is 10 to the power of 6. You can see here, this is 10 to the power of 6. After 10 to the power of 6 cycles, the component will not break at all. ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಇಲ್ಲಿ ನೋಡಿ 10 to the power of 6, ಇದಕ್ಕೆ ಏನೋ ಒಂದು ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಇದೆ. ಈ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂಗಿಂತ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ as ಸಿಗ್ಮಾ en. ಈ ಸಿಗ್ಮಾ en, say if it is around 300 MPa, see if you make use of any stress and if the magnitude of induced stress is less than 300 MPa, the component will not fail at all. Then this particular value of strength is what we call as endurance strength of the material. This is what we call as endurance strength of the material. Now, what is endurance strength? By going by this concept, we can say that this level of stress, the magnitude of stress below which there will be no failure of the component. The magnitude of stress below which there is no failure of the component. Such a value of strength is called as endurance strength of the material. Correct? The concept artha agidiya? Is the concept clear? Endurance strength ಅಂದ್ರೆ ಏನು ಅಂತ ಅರ್ಥ ಆಯ್ತಾ?
ಇನ್ನೊಂದ್ಸತಿ ಹೇಳಿ ಸರ್.
ಸೊ ಬೇಸಿಕಲಿ ಏನಾಗುತ್ತೆ, ನಾನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಒಂದು ಕಾಂಪೋನೆಂಟ್ ತಗೊಂಡೆ, ಸ್ಟ್ರೆಂತ್ ವ್ಯಾಲ್ಯೂನ ಡಿಕ್ರೀಸ್ ಮಾಡ್ಕೊಂಡ್ ಬರ್ತಾ ಇದ್ದೀನಿ. ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ನಾನು 500 MPa ಅಪ್ಲೈ ಮಾಡಿದ್ದೆ, ಆಮೇಲೆ 450, ಆಮೇಲೆ 400, ಆ ತರ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂನ ಕಡಿಮೆ ಮಾಡ್ತಾ ಬರ್ತಾ ಇದ್ದೀನಿ, ಸ್ಟ್ರೆಸ್ ಇಂಡ್ಯೂಸ್ ನ ಕಡಿಮೆ ಮಾಡ್ತಾ ಬರ್ತಾ ಇದ್ದೀನಿ. ಸ್ಟ್ರೆಸ್ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ ಅಂತ ಅಂದ್ರೆ ಏನರ್ಥ, ಕಾಂಪೋನೆಂಟ್ ಜಾಸ್ತಿ ಟೈಮ್ ಬಾಳಿಕೆ ಬರುತ್ತೆ. ಹೌದಾ? ಕಾಂಪೋನೆಂಟ್ ಫೇಲ್ ಆಗಕ್ಕೆ ಜಾಸ್ತಿ ನಂಬರ್ ಆಫ್ ಸೈಕಲ್ಸ್ ತಗೊಳುತ್ತೆ ಸ್ಟ್ರೆಸ್ ನ ಕಡಿಮೆ ಮಾಡ್ತಾ ಬರ್ತಾ ಇದ್ದಾಗೆ. ಸೊ ನಾನು ಏನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಸ್ಟ್ರೆಸ್ ಕಡಿಮೆ ಮಾಡ್ತಾ ಇದ್ದಾಗೆ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಬಂತು. ಇದು 300 MPa ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. ಈ 300 MPa ಗಿಂತ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಏನಾದ್ರು ಕಡಿಮೆ ಇಟ್ಬಿಟ್ರೆ, ಈ 300 MPa ಗಿಂತ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಕಡಿಮೆ ಇಟ್ಬಿಟ್ರೆ ನಾವ್ ಎಷ್ಟೇ ಸೈಕಲ್ಸ್ ಆಪರೇಟ್ ಮಾಡ್ಬೋದು. 10 to the power of 6, 10 to the power of 7, 10 to the power of 8, 10 to the power ಎಷ್ಟೇ ಸೈಕಲ್ಸ್ ಆಪರೇಟ್ ಮಾಡಿದ್ರು ಕಾಂಪೋನೆಂಟ್ ಫೇಲ್ ಆಗಲ್ಲ. ಯಾವಾಗ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಥ್ರೆಶೋಲ್ಡ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಸ್ಟ್ರೆಸ್ ಇದೆ, ಆ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂಗಿಂತ ಕಡಿಮೆ ಏನಾದರೂ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ ಇದ್ರೆ ಕಾಂಪೋನೆಂಟ್ ವಿಲ್ ನೆವರ್ ಫೇಲ್ irrespective of the number of cycles that you operate. Then that particular value of stress below which the component will not fail when it is subjected to cyclically repeated load is called as endurance strength of the material. ಅರ್ಥ ಆಯ್ತಾ? Okay, don't worry. You just I will end my class here. ನಾಳೆ ಕ್ಲಾಸ್ ತಗೋತೀನಿ ನಾನು. I will just demonstrate this again. Don't worry. Let us meet in the next class. You can leave the class and you can join OM class now. I will just explain this concept again in the next class as well. Okay?
Yes, sir.
Okay, fine. You guys can quit and join OM class.
Thank you, sir.